Okay, great. Great. Thank you very much. Welcome back, everybody. Our next speaker is Vanessa Frias-Martinez, and she is an associate professor in the iSchool and UMIACS, and an affiliate associate professor in the Department of Computer Science at the University of Maryland, where she also leads the Urban Computing Lab. So welcome, Vanessa. Thank you so much for joining us. And please take over, and we will listen with rapt attention.
Thank you, Rob. I'm going to share my screen. Okay, I'm going to move this. Okay, so hello, Rob. Hello, everyone. It's a pleasure to be here. I'm going to be talking today about a recent award from the National Science Foundation that we received, and about how parts of that research are being currently implemented on the cloud or through cloud solutions. The work is part of a large NSF award together with the University of Baltimore and Morgan State University, and we received this award back in October 2020. Okay, so the main reason behind this large project was that we received, prior to the large NSF grant, we received a small planning grant, which allowed us to explore, mostly through focus groups with West Baltimore residents, what were the main challenges that they were facing on a day-to-day basis, and how we could potentially solve some of those challenges through technological solutions. And so one of the main salient themes that we identified through those focus groups was the low quality of the public transit solutions in Baltimore City. This is not only an issue for residents or low-income residents in Baltimore City, but also across many American cities in which the public transit experiences that low-income residents have are not necessarily as simple as those from other income levels, and generally the trips that they make when they use public transit are either multi-transfer, meaning that they they might be using the same public transit, say for example a bus, but they have to go through multiple transfers, so take different bus numbers. And oftentimes it's also complex because these are multimodal experiences, in the sense that they do not only have to transfer multiple times, but highly probably they might also be changing the type of public transit that they use. So they might be combining bus with light rail or with metro. And so this obviously is not only a barrier for low-income residents to use or to fully access public transit, but it's also a problem because currently transit agencies are not really aware of these complexities, or these complexities are really hard to be measured, because oftentimes the way transit agencies try to understand the quality of the service that they offer is just by looking into specific public transit types or specific bus numbers or specific light rail lanes, and not at the connections between, or at the transfers between these two. And so if we can't measure the problem, then it's very hard to solve it. Just to give you an example in Baltimore City, so the way Baltimore City works is public transit is basically under the purveyship of both the state of Maryland and the city of Maryland, of the city of Baltimore. So parts of the public transit are taken care of by the MTA, which is the Maryland Transit Administration, and parts of it are taken care of by Baltimore City Department of Transportation. And so the only measure that they currently have of the quality of service that they offer is basically through an online survey that it's called Rate Your Ride. And Rate Your Ride only collects information for one public transit at a time. So for example, if you took bus 22 and then bus 53, you have to fill out the form twice and offer, whatever rating you want to offer. And then also a second problem, missing basically the information of the transfer experience. How did that transfer take place? Did you have to wait for a long time? Did you feel safe when you were transferring? And so, transit agencies are completely blind to this type of information, but also the timing of the surveys. Like a lot of participants decide to, take this survey online, but it's highly probably after a few days of taking the trip. And so, the way you recall your experience in public transit might be different from when you actually experienced it. So, both lack of information about how these transfers happen and the barriers in transferring, and also lack of timing or of real-time capturing that information are sort of two issues that transit agencies are currently, lacking in how they collect the information. And also, while we were running our focus groups with communities in West Baltimore, besides the fact that public transit was bad and they felt that, their experiences were terrible, they also complained quite a lot about how they felt that communities were always the last ones to know about the types of improvements that were going to be done in the public transit affecting their communities. And this has sort of a long story in that in 2015, in Baltimore City, there were plans to build a mass transit light rail connection that could basically connect the east with the west side of Baltimore, and that didn't happen. And so that was a massive loss for a lot of low-income communities that are concentrated on the west side of the city. And after that, there's been minor improvements, but they really haven't solved the main issue that low-income communities have, which is, very poor connectivity with other parts of the city. And again, long trips, lots of transfers, and oftentimes multimodal trips. And so basically, after these outcomes that we learned from the focus groups, we realized that there were two important needs to attempt to improve public transit in Baltimore City. The first one was to be able to identify and characterize what were the specific challenges that low-income residents were facing in Baltimore City. And, again, let me emphasize that low-income residents have very complex trips compared to what other people experience when they use public transit. And then the second important component was that residents want to be part of the solutions that are being discussed. And so we wanted to put an emphasis on bottom-up crowdsourced informed solutions. So basically put the communities at the center of, once we have the information of what are the challenges that these communities are facing, how can we bring together the communities that are suffering, the poor public transit, together with transit agencies and with advocacy groups, and sort of, try to come up with solutions in a community-centered manner. And so this was basically the idea that we proposed in the NSF project that we were recently awarded. We call it BALTO, which stands for Be an Advocate for Public Transportation. And again, the idea is that the communities themselves will be at the center of the data collection process, but also at the center of any type of discussions that are being made in terms of what could be the solutions for the poor state of the public transit that they currently have. And so I'm going to first describe the toolkit that we proposed. Obviously, this is an NSF grant, so it's not purely an implementation effort, but we oftentimes find that it's easier to explain the research questions once we have explained the toolkit. And so, let me go it this way. So basically what we propose to implement to be able to collect what were the barriers that low-income residents are facing when they use public transit, we proposed, first of all, to develop a mobile app, which we call BALTO app, which we'll use to collect mobility experiences. Then there's a second component in the toolkit called BALTODash, which is basically a dashboard where communities will be able to see in an aggregated manner the data that they have collected and the barriers that their own community faces. And then a simulator that we call BALTOSim that basically will allow us to explore how solutions implemented in one community might impact other communities in the city. So for BALTO app, as I mentioned before, so what's extremely important for transit agencies, and they are also partners in this grant, so both MTA and VCDOT are funded partners in this project. And what's important for them is to be able to collect highly granular information about the door-to-door mobility experiences that residents have when they use public transit, but also to be able to collect almost in real time quality of service surveys. So basically surveys about how residents feel about their experience, both aboard, but also while they are transferring from one public transit to another. And so what this BALTO app is going to do is basically is going to be collecting both passively GPS data when residents are using public transit, and also whenever they transfer, exactly at the time of transferring from one public transit to another one, we'll be asking them to fill out quality of service surveys. And so in this way, we'll sort of be solving the two sort of needs, information needs that transit agencies currently have. On the one side is fully understand what are the complexities in like multi-transfer and multimodal trips, and on the other hand, understand in almost real time, what's their perception of the service that they are receiving. The second tool in the toolkit is what we call BALTODash, which is basically once we have collected mobility patterns from residents from different neighborhoods, and this is, by the way, a neighborhood-centric tool. So each neighborhood and group of residents will be collecting data for their own neighborhoods. And then each neighborhood will be able to use BALTODash to explore in a dashboard what are the barriers that they face, like, how long does it take for them to go from home to work? How long do they have to wait in between transfers? What are the alternatives that they take if the transfer was too long or if the bus didn't show up, right? So all of these sort of behaviors at an aggregate level will be explorable in this dashboard. And then finally, the simulator. It's basically an effort that we are doing. The community will have access to it, but this is mostly for the transit agencies so that they can sort of understand whenever one community comes up with a suggestion for a solution, say, for example, increasing frequency or slightly changing the route or adding a new stop. I mean, what could be the impact of those solutions in other neighborhoods in the city? And so that's the reason why we're building this simulator, to understand the citywide implications of specific neighborhood-centric solutions. And so to give you an idea of how this toolkit will be used, which again, this is still very much future work, but basically the idea is that residents in different neighborhoods in Baltimore City will be using BALTO app to collect their mobility experiences. Then at the neighborhood level, there will be community meetings where residents and advocacy groups will come together. They will use the dashboard to explore what are the barriers and potential solutions. And then finally, we'll run workshops with the transit agencies, the MTA and Baltimore City Department of Transportation, with the advocacy groups and with the residents to discuss findings and brainstorm about potential solutions. Again, bridging the gap between lack of information about the barriers that they face, but also about having those solutions being community-centric and having residents always informed about how the decision-making process is done. And again, I'd like to emphasize that we have many partners in this grant. First of all, the residents from various public housing locations. We are partnering with the Housing Authority for Baltimore City, HABC. We're also going to be working with various other neighborhood organizations from Baltimore City. Other funded partners are two transit advocacy groups, CMT and BTEC from Baltimore City. And then we're also collaborating with a Maryland Transportation Agency and with the Baltimore City Department of Transportation. And so, again, I mean, I will talk a bit about the components that we have implemented in the cloud, but again, we just started in October, so, I don't have a lot to talk about. So, I mean, let me first describe the research trusts, and then I'll go to, the components that we're currently implementing in the cloud. But I wanted to take this opportunity to also give you a high-level overview of some of the questions that we're looking into and that will be eventually implemented in the cloud as well. So to develop the toolkit that I just described with the mobile app, the dashboard, and the simulator, basically there's a whole set of research questions that need to be answered. The first research thrust that we are now looking into are, first of all, understanding what are the privacy barriers that residents face. So, I mean, we're going to be collecting GPS data in the background when they use public transit. but it's going to be door to door, so on and off public transit. We want to understand the concerns that they have, but we are also looking into what kind of levers we could put in the mobile app in a way that residents could feel comfortable sharing their location information. And that might mean that we might not be able to collect their GPS locations every 5 seconds, but maybe it's with less frequency. And so we want to understand, and we are currently running focus groups trying to understand what are the different perceptions and how these could be implemented into the tool in a way that all participants feel comfortable with the data that we are sharing. Of course, that will impose problems in the data analysis, right? If we don't have it, the GPS data is not collected with high frequency, the behaviors that we will be able to mine from the data might not be as accurate, and all those are problems that we are very happy to face as long as residents feel comfortable with, the data that it's being collected from them. We are putting privacy at the center of it all. And then another important question is also, we are going to explore different survey strategies that might work better or worse. And so, what are the types of questions that we can ask, how many questions, with what frequency, what are the incentive mechanisms that might work. So all these questions surrounding the surveys that we're asking residents to fill out are also questions that we are going to be exploring in the research. Second large component is obviously, once we collect these GPS traces, we have to analyze them to understand behavioral motives. How is it that people are using? Where is it that people are spending more time? Where is it that they are waiting for too long? Where is it that they feel or don't feel comfortable waiting, etc.? And then we're going to be looking into transit equity questions about, trying to look into areas where there's supply but there's no access, right? I mean, so having a bus line in front of your building or a metro line in front of your building doesn't necessarily mean that you can use it, because maybe you cannot afford it. And so we're going to be looking into these nuanced choices of public transit. Then a third large research thrust, and this is going to be the focus of our partners at the University of Baltimore, it's basically understanding how we can facilitate conversations between residents and transit advocacy groups and transit agencies in a way that they are meaningful for everybody, and that solutions come out of them, right? And so how do you make all stakeholders participate and feel equally respected in those conversations is something that we are also going to be exploring through many focus groups. And then the fourth and last research thrust is the simulator that I mentioned before, in which we will try to build high fidelity simulators of how people move in the city, and also try to understand quality of service predictions. Okay, and so basically going back to the toolkit that I described before, we have three different components: the mobile app, the dashboard, and the simulator. Since last October, we've been working a little bit on the implementation on the mobile app and heavily on the focus groups to understand privacy concerns from the residents. And again, this has been a little bit postponed because of COVID-19, and running focus groups has been really challenging. And so, we're a little bit delayed with that, but we are moving forward slowly. And so today for this conference, I'm going to be talking about how we are implementing the mobile app. It's not fully finished, but how we are implementing it and how we are using AWS for its implementation. Okay, so the requirements for BALTO, once I describe the main characteristics of the BALTO app and the cloud, I will mention, I will talk a little bit about why we chose to do it on the cloud. But first, let me give you details about what is it exactly that we have implemented, that we are currently implementing. So for this mobile app, again, remember that we want residents to basically log into the app, declare, we're going to use the mobile app as a diary. Okay, so it's basically every time they make a trip, they are going to be basically declaring the trip, and then the data collection is going to start passively in the background. And then whenever they transfer, we automatically detect transfers. And whenever they transfer, we'll be asking them to fill out a survey. And so for the mobile app, first of all, we need to authenticate users. The users will need to log in. Not everybody, this is not going to be an open mobile app. users will be invited to use the app, and so they will be assigned login and password. And so we needed to have login functionalities for users to be able to log in. The second component or important requirement that we had for the mobile app was that once a user logs in, different groups of users are going to be assigned to different testing groups. Remember that I mentioned before that the surveys, like different residents are going to be assigned to different types of surveys. We want to understand whether, for example, longer or shorter surveys, or surveys that have multiple choice questions versus open-ended questions. I mean, which are the most appropriate types of surveys? That's something that we want to test. And so different residents will be assigned to different types of surveys. So upon login, the mobile app will need to retrieve information about what's the group that that resident has been assigned to. And that group will basically locally determine the types of surveys that we show to the end user. So that's a second functionality that we need. How do we store and retrieve meta information that the mobile app needs to retrieve upon the first login to the cloud? And then finally, obviously, the user is going to be, the mobile app locally on the cell phone is going to be collecting GPS data points, and it's also going to be collecting quality of service surveys as the trip is taking place. And we need to upload all that information to the cloud to then, run all the analysis that will be shown in the dashboard. And so we decided to use AWS among all the cloud solutions, mostly because some of us in the group were already familiar with Amazon services, and we decided to use it. And then, given the requirements that I just mentioned, we are currently using 3 different solutions. We're using AWS Cognito for the authentication, DynamoDB just for the meta information retrieval, and S3 is where we are storing all of the GPS and survey data. Okay, and as I said before, Cognito is to sign in, DynamoDB is to basically, we're using a database to retrieve the meta information when the resident logs in for the first time, and then S3, we're using it to store, the information that we are collecting from the users. In principle, we are using S3 mostly because our plan is, at least for the first tests, to just download all the data and analyze it locally. We are also evaluating, how to do that in real time for the dashboard, but right now we just wanted to store everything and then download it locally. To use these 3 AWS services, we're basically using AWS Amplify, basically in the full stack app development, and AWS Amplify provides access to many AWS services, including the ones that we are interested in using. And so, for Cognito, we are basically using Amplify to authenticate the user. For DynamoDB, we're using Amplify to retrieve meta information. So once the user logs in, we retrieve that information from DynamoDB. And then we're using Amplify storage to basically just upload a file to S3. And this is sort of the architecture that we currently have implemented. So on the left-hand side here, you see the Android component. Here you see the Amplify services. Here you see the AWS services, right? And so let me break this into the 3 different components that I just mentioned. So this is basically whenever the user basically logins for the first time into our mobile app, they will have their own login and password, and through Amplify authentication, they will basically use AWS Cognito. And if they succeed in logging in because they were given a password and a login to access the system, they'll have direct access to the dashboard of the app, where they'll be able to declare trips and start the data collection. Then on the other hand, as I was saying before, when the resident logs in for the first time, we also need to retrieve meta information about the types of surveys that we're going to be showing them, and also the types of incentives. Different users, different residents will be exposed to different types of surveys and different types of incentives. And so that's information that has to be retrieved from the cloud and that will be stored locally on the mobile app. And so once that data is stored, whenever the resident starts, declaring trips, and we start collecting GPS data and quality of service surveys, basically, before showing the surveys to the resident, we'll check those meta values to see what type of survey the resident needs to be shown. And then finally, rather than uploading GPS data points in real time because of lack of internet access or real-time internet access for some of our users or residents, we decided to actually zip all of the data at the end of the trip. So we are taking all of the GPS points and all of the surveys that the residents have filled out during their trip. During one trip, we are zipping that data and we are basically using Amplify storage to upload it to S3. So this is just, again, as I was saying before, we started in October. So this is what we've been doing so far. Obviously, we have the dashboard and the simulator that highly probably will also be implemented in the cloud. But right now, this is what we have. And so why did we decide to choose cloud solutions rather than implementing that locally? So we just thought that for the types of functionalities that we were looking for, most of them, were already implemented in AWS services, and it didn't make any sense for us to implement from scratch logging information or data retrieval and data storage. So it was, much more simpler to basically use services that already implemented that for us, right? And oftentimes that meant just, as I wrote here in the slide, oftentimes it just meant one line of code as opposed to, having to implement the whole service on ourselves. So it really saved us a lot of time. Having said that, of course, I also think that any cloud solution for any of us, PIs, students, has a learning curve. And so at the beginning, it might feel like, you're investing a lot of time to learn how to run one line of code. But, in the end, I think that it really speeds up implementation in the long run. And also for us, it's been very helpful to take advantage of some of the support networks that have been offered. So for example, we are very grateful for all the contacts and help that we've gotten from CloudBank and also from the AWS academic partners. So whenever we've had questions, they've also made themselves available. And so I think that, those two are two great resources. And finally, let me finish this talk by saying that, as I was mentioning at the beginning of the talk, this is a really large effort. I've just mentioned here like a small implementation component, but we have partnered PIs at the University of Maryland, Chris Anton and Jessica Bitak, at Morgan State, Celeste Chavez, and at the University of Baltimore, Sima Iyer, and obviously all of their students. The BALTO app component that you've seen here is something that I've been working on together with Sad and Naman, who are two PhD students, and with two undergraduate students funded through the REU program from NSF as well, John and Juna. And I think that's it. Thanks a lot. And again, I hope that next year we'll have many more details about cloud implementations. But right now, this is what we have. Thank you.
All right. Thank you so much, Vanessa. That was really cool and super elaboration of the case for cloud. We're so glad that worked out. And people may not know, but you are, I think, the Cloud Bank's very first customer. So we have a set of questions for you here. For one thing that occurs to us is the challenge of cost estimation if you're going to be going into the cloud, in addition to the learning curve aspect that you mentioned. So with such a powerfully crowdsourced project, it seems hard to guess how much resource you'll need for your infrastructure. So how did you approach putting together your cost estimates when you went into the funding process?
Yeah, so the way we sort of managed to approximate costs, I think that our final decision was to cap the number of participants in the project. And so what we've done is that we decided to basically say, okay, so for each neighborhood we are going to be working with, we'll extend an invitation to say 100 residents from that neighborhood. And so by limiting the number of participants for each neighborhood, that's the way we could come up with approximate costs. And also we are controlling not only for the number of participants, but also for like how frequently they collect trips and how many trips they collect. So, and I think that we can do that because we're working closely with all of the communities where residents are going to participate with. So, you know, the HABC, which is the Housing Authority for Baltimore City, we are specifically working with the staff members from various public housing units. We are going to the public housing units and talking with the residents. We are explaining them how to do the data collection. We are telling them, okay, you have to collect, I don't know, 4 trips per day and only for 1 week. And so in this way, we are able to control very precisely, you know, the number of trips that we'll have per resident and how many residents we'll have. And then approximately, we assume that each trip would be 1.5 hours long, and we approximately calculated how many GPS points could that be. And so I think that that was the way we did it. Mostly the 2 things that I would suggest is by, rather than making it fully open and crowdsourced without, you know, knowing how many participants you're going to have, if you can collaborate with, you know, partners locally, sort of to control the number of participants that you're going to have, that's key. And then, you know, be in direct contact with the participants and make sure that you are clear about expectations in terms of how many trips they have to collect, and you know, limit that as well. I think that those were the 2 things that we used to.
It's really cool to hear about the social integration. That it sounds like it wasn't particularly a challenge to get enough people to sign up, that you had that kind of aspect of it covered. So
I mean, really... so let me clarify. So I mean, that's what we are trying to do. So it's been a challenge because of COVID. So imagine, I mean, working with you know, low-income residents in general is more challenging because they have very complicated lives, and, you know, participating in a project like this is, I mean, you're taking time from their already very limited time. And so now with COVID, it's been more challenging because we've been trying to do all of this online. Now it's getting better. We're going back in person, masked up, but, you know, we are going back to public housing units and meeting residents and talking with them. So things are getting easier, and residents are definitely eager to participate. And I think that this is also due to the fact that we've been working with these communities for a long period of time through the NSF planning grant as well. They already know us, and they are really, you know, eager to have public transit improved, because you know, that would improve their lives as well. So I think that it's also a mix of having a problem that they really feel very passionate that they really need to you know, to change and improve, and also about having a sort of a longer community relationship with the people that, you know, we're working with.
Yeah, trust relationship. Yeah, that's cool. So let me move on. We have time for a couple more questions here. This one's a bit long. The data encrypted, particularly if stored in S3, are there any concerns about the data being identifiable or not? For example, can the GPS information be used to pinpoint a resident's particular address? So privacy questions.
Yes, so the way we are doing the mobile app is being used as a diary. And so the resident needs to declare, like, you know, I'm starting from home, and then I'm going to take this bus, and then I'm going to work, or whatever they want to declare. But if they declare that they are living from home and they start the collection from home, then yes, we will know that that's their home. Having said that, I mean, again, because of the way we are asking residents to participate with us, I mean, we already know their name, we already know where they live, because we are working with very specific public housing units. And, you know, that's an important component. I mean, the data is going to be aggregated, so by no means the dashboard is going to be showing any individual trip, but we need to know what's the housing unit that person is coming from, because oftentimes these public housing units only have like 1 bus stop. And so we really need to understand, you know, what are the changes that need to be made at specific public housing units. And so yes, I mean, short answer is yes. The data will have the location of where the person lives if the person chooses to declare that, of course.
Okay, cool. Let's see. I think we're close to 11:05, so let me do a last question here. See, can you give us a sense of how large your data set is, or how large you anticipate it going to be, and sort of the scope of your considerations in that sense too? Does this feel like the infrastructure that you're building is going to be manageable, or is it sort of feel like there's aspects that are open-ended and maybe a little daunting?
So okay, I mean, we're going to be, as I said before, we're going to be limiting the number of participants that are going to be collecting their data. And so right now, the numbers that we are managing are around between 100 and 200 participants per neighborhood. We are looking into up to 8 neighborhoods, so up to roughly 1,500 participants. In terms of data collection, the incentives that we are offering are going to be for up to 4 weeks of data collection. We're going to collect 4 weeks throughout the year in different, sort of time periods. And so we're roughly looking at 1,600 participants for 1 month of data per person, and around 4 trips per day for each person. So, I mean, this is not a big data project like, the big data that we think of when we think about, I don't know, cell phone data, right? I mean, I've worked a lot with CDR data or with location intelligence companies data. This is not that magnitude at all. We are rather looking for, a smaller subset of data that will tell us something about a very specific population about the needs for that very specific population. So in our case, the cloud is not so much to manage a large magnitude of data, but rather to facilitate the data collection process and the logging and the storage and everything.
Yeah, it was very impressive the way you integrated all those different tools, particularly the Amplify. That's really neat to use, see the use of higher level cloud services. So with that, we're at time. So I want to say thank you again so much for sharing with us your project. That's really cool to hear about, and it's really neat to see the social impact aspect, as with the previous talk also. So thank you very much, and I'll address everybody. We can stop recording at this point. And we are going to now turn to a 5-minute break. So we'll be back at 11:10, where we will pick up with the IBM Cloud Research Use Cases presentation. So